Well, in the diagram below, A, B, and D are the vertices of a rectangle ABCD. The equation of AD is y equal to 2x plus 16. Line AB cuts the y-axis at G. The x-intercept of line BC is F, and the angle of inclination of BC with the positive x-axis is alpha. The diagonals of the rectangles intersect at M. Now, question 3.1, as we can see there, 3.1 says calculate the value, calculate the coordinate of M. All right. So I'm gonna write the question here, 3.1. We're looking for the coordinate of M. Okay. We can see that because it is a rectangle, the point M here is the midpoint of the line AC. Okay. Okay. Remember, a rectangle is also a parallelogram, so it's the midpoint of AC, and the midpoint is given by the formula M equal to x1 plus x2 all over 2, and then y1 plus y2 over 2. So M will be equal to I want to say -7 plus 6 over 2, and then 2 plus 3 over 2, which means that M, the midpoint M, will be equal to -1/2 and 5 over 2. That's the midpoint. Okay. Question 3.2 says write down the gradients of BC in terms of P. Okay, right here, question 3.2. 3.2. We want the gradients of BC in terms of P. So when we look at the points B here, the coordinates of B are unknown. Okay, we have like x, y. So how can we get this in terms of P? All right, now it is important to note that gradients for straight lines are constants. Okay, so meaning the portion from B to F, okay, from the point B to the point F, this gradient here is the same as the gradients from F to C. Okay, they're the same. It's gonna be the same gradient. So now, if I need to find the gradient of the line BC, this means that I can find the gradient of CF because it is the same gradient as BC. So here I'm asked to find the gradient BC, and then I said that the gradient of BC is the same gradient as the gradient of CF. Okay, so this will be then, and then the gradient formula is given by M will be equal to y2 minus y1, the change of y over the change of x. Okay, so this will be then 3 minus 0, so 3 minus 0 all over 6 minus p. Okay, and then this is equal to 3 over 6 minus p. Careful here, do not ever simplify this part. Okay, you cannot simplify 3 and 6 there. No, you cannot, because here at the denominator we have like two different terms. Okay, that's so therefore the gradient BC is just equal to 3 over 6 minus p. So now that the gradient BC. And then the following question says, let's move a little bit up there. Question 3.3, it says, hence calculate the value of P. Well, excuse me. All right, I'm gonna write the question. I'll move my board over here. Let's see. 3.3. So we need to find the gradient. Okay, we need to find the value of P. This is what we're looking for. Great. So what do we know from the question? I think maybe I can just post a diagram over here again. Yes, diagram. Now, so we need to find the value of P. What do we know? Okay, because this is a rectangle, it means that the lines are opposite sides are parallel. So meaning this side is parallel to that side. Okay, so we also know that parallel sides have equal gradients. Parallel lines have equal gradients. So I want to say here AD is parallel to BC. Okay, so the reason is that because it's a rectangle. Okay, rectangle or parallelogram. Rectangle. Now, I said therefore the gradients of AD it must be equal to the gradients of BC. Okay, and the gradient of AD is just the coefficient of x because this is written in the y-intercept form. Remember, the y-intercept form is equal to the gradient intercept form is y equal to mx plus c, where m is the gradient of a straight line. So the gradient here is just 2. So over here it's 2, and then the gradient is 3/6 minus p, as we calculated in the previous question over here. Now, to find p, we can just cross multiply. Okay, because here the denominator is 1. If we cross multiply, we're gonna say 2 times this denominator and then 1 times that numerator. So that makes 2, 6 minus p equal to 1 times 3. And then that makes 12 minus 2p equal to 3. So if I move the 12 over, and that would be negative 2p equal to 3 minus 12. Okay, and that makes negative 2p equal to negative 9, and then p will be 9/2. So that's the value of p, 9/2, or it can also be written as 2 gets into 9 4 times, 4.5 is left. So this is the value of p. And then the following question is, let's see, question 3.4. 3.4 says, 3.4 says calculate the length of dB. So I think I'm just gonna move my board over here and then split it like 3.4. Calculate the length dB. We're looking for dB. Okay. Now let's first post the diagram over here. Okay, here's the diagram. Fine. Now we need to find the length dB. How can we do that? Okay. The given shape here is a rectangle. So one of the properties of the rectangle is that the diagonals are equal. Okay. So dB is just because dB, the coordinate of B are unknown, of D and B are unknown. So but we know that dB must be equal to AC, because the reason is that's the rectangle diagonal of the rectangle. Okay, of the rectangle. Now, so I can just work out the length. Okay, the length of AC. So AC will be, I work out the length by using the distance formula. The distance is given by square root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay, and then we can say AC will be equal to -7 minus 6 to the power of 2 plus 2 minus 3 to the power of 2. and then AC will be equal to, we can use a calculator. Okay, let's first, before using a calculator, I can just quick out simplify this. -7 minus 6 is -13 to the power of 2, which is 169. Okay, plus 1. So we didn't have to use a calculator. This is just equal to, okay, this is equal to roots 170. Therefore, dB will be equal to square root of 170. I can't really simplify this, okay? If I can check in the calculator here, roots of 170, I think I'll leave it like that. The square root of 170 is going to be the same thing, okay? Yes, it's going to be like that. So dB will be square root of 170 units. If we want to simplify this, we can write its value. Okay, if we must press SD, the SD button, and this is 13.04. So 13.04 units. So that's dB. Okay. The next question. The next question says, calculate the size of alpha. So let's see. Okay, I see alpha. Let's move my board over here. .5, and then I think I'm going to post the diagram over here. So we are required to find, the question says, calculate the size of alpha. So alpha, we're looking for the size of alpha now. Okay, what is the size of alpha then? Okay, well, we said that these two lines are parallel, okay? Therefore, the gradients are equal. So if the gradient of this line is 2, the gradient of that line is also 2. Because it is 2, actually, because the gradient here is 2, I look at the coefficients of the x, because as I said in the previous questions, that this is like in the gradient intercept form. So the gradient is 2, the coefficient of x, and then because the two are parallel, then the gradient of BC is also equal to 2. Then we do know that the gradient is equal to tangents of the angle. So in this situation, the gradient is equal to 2. This will be equal to 10 of alpha. So if I need to find alpha, I'm just going to do 10 minus 1 of 2 in the calculator and then find the value of alpha. Now let's use the calculator. To do that, we press shift here, and then we press 10 to get 10 minus 1 of 2, close brackets, and then hit equal. Then we can see that alpha is equal to 63.43 degrees. 63.43 degrees. That's the value of alpha. Well, the following question is which one? The question says, calculate the size of the angle OGB. So we need to find this angle OGB. Let's see, where's OGB? Let's see that in the diagram. OGB, this one, okay. 3.6 OGB. So we're looking for this angle. Well, we can solve this in many different ways, okay? To find, there are many ways, but I prefer to do the way that seems to be easier. Okay, because we already find alpha here, alpha is equal to 63.43. We can notice that alpha, the angle alpha and this angle are equal because they're vertically opposite. Okay, I want to say here, angle alpha is equal to the angle OFB. Okay, the reason is that vertically opposite. Okay, angles are equal. So OFB is also equal to 63.43. And then this angle here is also 90 degrees because you know, this angle is clear, perpendicular. The y and the x-axis are perpendicular, and then this also is 90 degrees because it is a rectangle. So we can work out the sum of the angle in the quadrilateral is equal to, in this quadrilateral, like just show the quadrilateral. In this trapezium, sum of the angle will be 360 degrees. Okay, so we have like 360 degrees will be equal to OGB, okay, plus 90 plus 63.43 plus another 90. So you can notice that this is OGB plus 90 plus 63.43 plus 90, all equal to 360 degrees. Now I can move all this over, so let's just simplify. That's going to be 360 degrees will be equal to OGB plus, let's use my calculator, that makes 90 plus 90 makes 180 plus 63.43. Okay, so I first did 90 degrees here plus 90 degrees, that makes 180 degrees plus 63.43. This is equal to this number for 243.43. 243.43. So OGB, so if I move this number over, so that makes 360 degrees minus 243, 243.43 equal to OGB. Okay, if we minus 243 from that, we will get positive 116.57. That makes 116.57 equal to OGB. Therefore, OGB is just equal to 116.57 degrees. Then we got it. Then let's move to the next question. The question says in 3.7, determine the equation of the circle passing through the points D, B, and C in the form yx minus a squared plus, okay, let me write, I need to find the equation of the circle passing through, let's write this equal to r squared, passing through, that's how I abbreviate passing through, D, B, and C. Okay, that's the equation. That's the equation 3.7. Determine the equation of the circle passing through points D, B, and C in the form as given. Now, let's see. I'll move my board this way. And then I think I need just to draw the same diagram over here. I'm gonna put the diagram over here. Here's the diagram. So from the question here, okay, because we have like a rectangle and then we have a 90 degrees angle here. Let me do it this way. We have a 90 degree angle over here. I understand that this must be a D and C must be the chord of the circle that passes through the center M. Okay, and the circle may look like okay. It must pass. All I know, the circle must pass through something like this. I don't know how to draw my circle well, but approximately something like that. Approximately something like that. Yes. Okay, I got it. So D and B are the diagonals, are points, but it passes the diagonal because BD makes the diagonal because M must be the center, because this is a 90 degrees angle. Remember the property that says when we have like a 90 degrees angle here, the theorem, angle subtended over here. So we have like, okay, approximately my diagram is like that. Very good. Oops, almost. Anyway, I don't have to be accurate there. M is the center of the circle with coordinates. We did find the value of M previously. It was -1/2 and 5/2. Let's see. M was, yes, -1/2 and 5/2 over there. So -1/2 and 5/2. Okay, and then the radius must be the distance between M and any point on the circumference. So let's say MD, for instance. Do we know the coordinate of D, or do we know the coordinate of B or C? The radius will be then, how can we get the radius here? Oh, okay. Previously we did find that AC, we said that AC is equal to BD, equal to DB. We did find the length DB, which was square root of 170. Let's see, DB was, we found that the length DB, yes, DB was √70. So DB is being the diameter, the radius must be half of it. So the radius will be, I'll say therefore, MB will be, which is the radius, okay? MB is the same thing as MD, okay? And the radius must be half of 170. Then we can write the equation. Therefore, the equation will be x minus a half, that makes plus a half, okay? And then plus y minus 5/2, okay? And then this is equal to the radius to the power of 2. So this will be root of 170 over 2 to the power of 2. And then this will be the power of 2 over here. So that makes x plus a half to the power of 2 plus y minus 5/2 to the power of 2 equal to 170 over 4. And 170 over 4 is, by 2 is going to be 65, 80, okay, let's just use a calculator here. 170 divided by 4 equal to 85/2. So 85/2. So this is just 85/2. So this is the equation of the circle. Okay, and then the next question is question 3.8. Let's see. 3.8 is here. The question says, if AD is shifted so that ABCD becomes a square, will BC be a tangent to the circle passing through points A, M, and B, where M is now the intersection of the diagonal of the square ABCD? Motivate your answer. All right, let's first move my board over here, this side. Let's first move it like that. You have like 3.8. Okay, and then it is say that okay, here's the diagram. Now I think we should also put the question here so we can understand it better. Okay, here's the question and that the diagram. Let's just move. Okay, et voila. Now it is said that if AD is shifted so that ABC becomes a square, will BC be a tangent to the circle passing through points AM and B, where M is now the intersection of the diagonals of the square ABCD? Motivate your answer. Okay. Okay. So let's first draw the circle, okay, that passes through the point A, B, C. I just want to draw a rough sketch. No, I don't need to draw the rough sketch here. But now let's first see this way. Okay. In this situation, the angle AMB here will be 90 degrees because we're talking about a square now. Okay, the diameter, this over here, it's because the diameters of the square are 90 degrees. Okay, the diagonals are meant to see the diagonals of the square is equal to, well, I was saying this must be 90 degrees because the diagonals of square are the diagonal of square are perpendicular, they bisect each other. So this will be a 90-degree angle. Okay, over here it must be a 90 degrees angle, and because it is a 90-degree angle, and then this must then become the line AB then will become the diagonal. AB will be the diameter. I mean, diameter of the circle. If I could draw the circle here, okay, let's just draw that circle. The circle that passes through A and B, so it must be something like this. Let's call the shape a circle. Okay, I'm struggling to draw a proper circle here because you have a 90-degree angle here. According to the property for the chords, this must be a diameter. The line AB must be the diameter of the circle. So what else I want to say here, because like I say, because BC is perpendicular to AB, okay? BC, this line is perpendicular to AC. Therefore, I'll say BC is tangent to the circle. Thank you.